To our video here on vectors day 2. Nothing new coming out at you here. All we're going to do is just do one problem that is a free response. You see part A, B, C, and D with the one prompt, and we're going to go ahead and tackle this thing. So let's go for it. So here's our prompt. We have a particle moving along a curve in the xy plane. It has position x of t, y of t. So this is the position at time t with, okay, it gives us the derivatives. That's nice. It gives us dx dt, dy dt, and then at time 2, we have the position. Okay, so what's really nice is since it's giving us the derivative, just one thing I want to note here is it gives us the velocity. Okay, so dx dt represents the horizontal velocity. So this is going to be sine of t cubed, and then cosine of t squared. Again, I put those in those little chevrons. Right there. May or may not be useful, but I just like to have it like this just in case. So I have the velocity here in case one of these questions asks for anything to do with that. And I'm ready to go here. So it says, write an equation, the tangent line to the curve at the point where t equals 2. So tangent line to the curve, which means that I need... see here. I need the slope, so I need dy dx. Okay, and I need the x value, and then the y value at t equals 2. Now, what's super nice, people forget about this, is if you read the problem, at 2, I have the position here, which is totally awesome. So I have x is 7 and y is 4. So essentially, I'm going to be getting y minus 4 equals, got to find the slope here, and then x minus 7. And then I'm going to fill that in with whatever the slope happens to be. So I'll write it like this, dy dx. Okay, or the slope, whatever you want to think of. So that part, easy. Didn't have to do any calculus for that, really. Just had to read the problem. Now let's go ahead and do the calculus. How do I find dy dx? Well, if you remember, dy dx is equal to dy dt over dx dt, and which is something I have here. So this is cosine of t squared all over sine t cubed. Awesome. So now what's the slope at t equals 2? So you're going to plug in a 2. So I'm going to get cosine of 2 squared, which is going to be 4, all over sine of 2 cubed, which is 8. And at this point, you just type it in your handy-dandy calculator. I don't need to show you how to type this up in the calculator, so we'll just... Oh, you get a slope of negative 0.661. So my final answer here, combining what I have in green and what I have here in pink, I'll do that in baby blue, is I have y minus 4 equals negative 0.661 x minus 7. So that's part A. Again, I was given the 4 and the 7 right in the prompt of the question, and I just had to find the dy dx, which is nice. It already gave us the dx dt, so I'm really just using the formula, plugging in what we're given. Not a big deal here. Okay, speed. For speed, if you remember, is, and by the way, I have this little handy-dandy formula sheet here, okay? It has everything in case you're still not comfortable with it. So speed of the particle is when we square dx dt plus dy dt. That's also squared and square root all of that, okay? So this is the formula that we are looking here for speed. So all I'm going to do here is for speed, I'm going to get the square root of dx dt, okay? So it's going to be sine, and this is going to be at t equals 2. So it's going to be sine of 2 cubed, and that's all going to be squared, plus dy dt squared. So it's going to be cosine of 2 squared, and then that's all going to be squared. So this is what speed's going to equal. Okay, so this is speed. Again, you're literally just going right to your calculator, so it's not really that heavy with math right now. It's just knowing what are these things asking. So, oh, okay, and I get an answer of 1.185. I think it's a 1.857. So you can do 1.185 or 1.186. It's not going to matter. No units are necessary here because we don't have any units. It didn't give us anything. So that's good. That's speed. All right. So first two questions are just knowing two formulas, and you can get these points. Part C, so for a value of t between 1 and 2, does the tangent line of the curve have a slope of 4? Okay, and we're going to find the acceleration of the vector at this time. So we need the tangent to equal 4. So that's dy dx needs to equal 4. So since dy dx is equal to this right here, I already showed this work, so I can just say, okay, well, 4 can equal dy dx, which is cosine of t squared all over sine of t cubed. All right, and you just need to use a calculator for this. Easiest way to do that is just to graph these. Okay, you got to be sharp with the old calculator here. Put this over so I don't have any type of glare. What you can do here is type 4 into y1 and then type in this cosine. You can't do t, so you got to use x. Just deal with it all over sine of x to the cube. Make sure we're in radian mode, by the way. I'm going to check it because I teach other classes that might use degree mode. Okay, we're good. We're in radian mode. So all I'm going to do now is just graph it. Now, I know it needs between 0 to 1. So if I just want to just change my, that's not what I want, just from 0 to 1. Let's just see what happens here. So there's my 4. Here comes the curve. Here comes the curve. Where is the curve? There he comes. There's the curve. Very slowly. Okay, so find the intersection. You hit second trace. Pull up this menu. You want to intersect choice 5. Answer the 3 questions. First curve is blue. Second curve is red. You can guess. It doesn't matter if it intersects once. So you can just hit enter again. And then kablamo. You get t equals this 0.616. Okay. So I'm going to use all these digits, though, as I go ahead and find the acceleration. So real quick, now I'm actually going to do a little bit of calculus here. It's not a formula I need to memorize. Here comes really my first step of calculus here, coming in halfway through part C, is I need to find the acceleration. So to go ahead and find the acceleration, I'm going to take the derivative of the velocity, which is right here. Okay, and remember, I wrote out the velocity from this point right here. Okay, so the acceleration, so the derivative of sine of t cubed, this is going to require a little bit of chain rule here, so it's going to be 3t squared. Derivative of sine is cosine. Inside stays the same. Okay, and then we're going to go ahead and do the next one, which is derivative of t squared is 2t. Derivative of cosine is negative. I'm going to put that negative out in front. Sine of t squared. Okay, and then to find the acceleration at this 0.616 dot 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 dot, because we have to use all the decimals. If we cut it short, you might be off by a 1/10 or a 100th, and you will get 0 credit. So just be aware of that. So at this point, by the way, in my calculator, if I don't touch X ever again, X is saved. Okay, the X is saved. I go to the home screen. If I just type in X, boom, there's a whole dinghy right there. So I literally can just type in 3x squared. Again, I have to use X's. There's no T's in the calculator for when we're in this particular mode. All right, so that part's going to give me 1.109, comma, and then the vertical, just again typing this in exactly as I see it here. Just double checking my work here. Yep, I got it. So negative 0.457, and boom, that's good right there. All right, so that's acceleration, and of course part D is going to ask for position. So we have everything. So if we're given the derivative to find the previous position, you can take the integral. So we're going to take the integral of dx dt, you can find out what the horizontal is, take the integral of dy dt, find out what the vertical is, and put them together into one little vector, and then we be done. So I want to integrate dx dt with respect to t. which is going to turn into integrating sine of t cubed dt. Now, I really can't integrate this because I just can't. We don't have the skill set. But what's really nice is I can use the fundamental theorem of calculus. So if I'm given 2 points, I'm given 1 and I'm given 2 for time. So I'm going to integrate from 1 to 2. And this is going to equal my x of 2 minus x of 1. And I have x of 2. X of 2 is 7. So that is just 7 right there minus, I do not know, x of 1. So I can go to my handy dandy calculator and then type this one in. So this one, I would say, is a trickier one because you need to remember to use the FTC here. So let's go ahead and integrate. So hit alpha, F2 window, go down to the integral right here. Go from 1 to 2 of this sine of x cubed dx. And then kablamo, that gives me some 0.2 something, so 0.218. And there's more than that. So to solve for x1, I'm going to subtract the 7 over. So that minus 7. And then I'm going to divide by that negative 1 to make that positive. So x of 1 is going to end up equaling, when I divide by negative 1, you don't really need to write that in the calculator, but I will for you. It's going to be 6.7818. I'll just leave it like that. I'll write it like this. Okay, that's the first part. So for the horizontal, that's going to be the integral. We're going to do the exact same strategy now. We're going to integrate from 1 to 2 of the cosine of t squared dt, and that's going to equal y of 2 minus y of 1. Squeezing it out of there. Okay, so again, go ahead and integrate choice for 1 to 2. And I have to use FTC because I cannot integrate this by hand, so I can't use the plus C method of, okay, solving this integral plus C and then plugging in the value 2 to find it. I can't do that. So I have to do it this way. There actually is a way to take the integral of this. We actually haven't learned that yet. Can you believe that? There's more integration techniques to come. Well, we can approximate it, put it that way. All right, so here you're going to get this negative 0.4 number, negative 0.443. There's more to that. Y of 2, it says, is 4 minus y of 1. So we need the same strategy. So I'm going to subtract 4, divide by negative 1. I don't think I divided by 4. Sorry, not divide by 4. Subtract 4. Subtract 4, and then now I divide by negative 1, and that probably is a little more accurate. So this is going to give me y of 1 is 4.4430. So my final position is going to be the x goes on this side. You have to write it as a vector to get credit. I don't care if you do a 1 or a 2. I like to truncate. I'm a truncator. And then boom, there you go. So there is an entire free response all done involving vectors. And that's it. Now you should be close to an expert on vectors.